Okay. So hello everyone, this is Akshay here, and let us start with today's question of our GFG P So given today's question name is count number of substrings. So we have been given a string of lowercase alphabets. We need to count all possible substrings, not necessarily distinct, that have exactly case distinct characters, right? So for the given string ABA, we need to form all the possible substrings in which there are exactly k distinct characters. So you can here see A and B, right? So the number of distinct characters, that is A and B, that is 2. Similarly for BA it is 2, and similarly for ABA it is again A and B, the distinct, right? With rest A is repeated twice. So there are two methods to solve this question. First method is using that form all the possible substrings which you can, and just do as the question says. So the time constant would be again O of n square, and since we want to check in each possible substring, we need to check the count of distinct characters, right? So avoid the duplicacy. Either we can use here a hash set, so I'm using hash set, or you can use a array or array of size 26 where you can keep on incrementing the count, right? You can do that as well, and you can use hash set also. For this video I'm using hash set, and let us code that approach, and then we can move ahead with the step 2. Okay, so please pause this video, try to code this brute force approach, and then we can proceed ahead with the method 2. Okay, so that is the code for method 1. So let us compile and run. Let me give a very quick code walkthrough that we have using a 2 nested for loop, and before going to nested for loop we are using a hash set. We are always adding the current characters of the current substring into the hash set, and then we are just checking it in the bottom condition that if distinct count is equals to k, then we need to return our answer plus plus, and if it is greater than equals to k, break. So why it is there that even though in a particular substring, let's say the distinct character count is itself is exceeding the k, then no need to check further, no need to push the further characters of that particular substring in the set, right? I hope that makes sense. So you can see for 147 it passes. For all the rest case we got the TLE, and let us do a constraint analysis as well. So it is 10 power 6, and we are using n squares. We are using the iterations 10 power 12, which is definitely greater than 10 power 8, and that is why we are getting a TLE. Let us move ahead with the optimized one. So here we will use a 2-pointer, a sliding window technique. So let us do some dry run on it, and but the actual crux is what we are going to do here is, okay, so what we need to do here is, so let us assume that we have figured out a way in O of n that is finding that is implementing a function which can find the at most k distinct uh, repetition in a string, in a particular substring, right? That means I'm saying that I am considering all the possible substrings. Let's say for A, B, A, the possible substrings are, let's say, A, and then B, and then A again, right? And what are the possible substrings? So it would be AB, then BA, and what else? ABA, right? So this is, and let's say k equals to 2. So this was the all the possible substrings where the distinct character was at most k. And what is the meaning of at most k? At most k means that k can be equals to 0, k can be equals to 1, k can be equals to 2, right? But not greater than the given value of k, right? So that means this is the all the count of the substrings which can have the distinct character counts at most k. So what is the length here? It is 1 2 3 4 5 6 and 7, right? You can clearly see that. What we're going to do is that we can solve this thing in O of n. So if we can solve till at most k, I can get the count, right? Let's say it's x. So I will run this function again for, let's say, k minus 1, and let's say this is y. So definitely I can return x minus y to produce our desired output, correct? So in this case k equals to 2, and you have this thing. So for k equals to 1, k equals to 1 in ABA string, the at most should be 1, right? One distinct character, 0 or 1. So it would be A, B, and A, correct? And that's it. So if you minus, so it is how much character? Count is 3. So if you will do 7, or am I missing something? 1 2 3 4, it is 6, not 7, right? It is 6. So 6 minus 3 will give you as 3, and which is given in your first input test case, right? Which is given in your first input test case, it is 3, correct? So now we need to understand that how we can find the utmost k distinct, how we can implement this function in O of n, right? So let us do that, a dry run here. So we will be needing a let's say array of size 26 to store the frequency of the given string. So let's say we have a b, right? The indexes are 0 1 and 2. So what we'll do, and k here is nothing but what 2, correct? So first of all, we will need two pointers. So first of all, I would be equals to 0 and j would be equals to 0. Here you will mark the frequency of a, right? So it would be a, b and c and so on. So since I have visited the first character, which is a, so I'll mark the frequency as 1. Correct. Now I'll keep on increasing my window until and unless my count, or let's say while count is greater than k, right? If this is not the case, if this is the case, let's say, then I will uh, decrease my window, or let's say start removing from start, or start, and for the start pointer what we have maintained I. In a window we are maintaining I as a start and j as end, right? Just remember this and let us proceed it with the dry run. So this, when this is not the case, when count is not greater than equals not greater than k, then we just have to keep our include in window size, else keep increasing window size. Okay, let us see now. Let us see now what is happening. So for a, what is the count here? The count is still the distinct characters count is still equals to 1, so it is not greater than 2, not greater than k. So what will happen, we need to include all the possible substring formation using this particular window, right? So I equals to 0 here and j equals to 0. So when my I and j is pointing to the same pointer, and I'm talking that how many possible substrings I can form using just this character a, I can clearly say only one substring is possible, that is a, right? So I, we have I and j. So can you express what is the total count of the possible substring? It is 1 now, right? For the current window. So can you express this particular count, possible count of for all substrings using I and j? Yes, I can. I can write j minus I plus 1, right? It will give you 1. And what is the string I'm saying? And I'm saying a. Since my count was 1, which is not greater than k, so I'll just keep on proceeded. That is, I'll follow in this case and I'll just go ahead. So the next is b, right? So I'll again increase my count of my new character, right? So it is 1. And since we have encountered b, so I will again increase the frequency to 1. Earlier it was everything was 0, correct? Now, what is the count of distinct characters? It is 2, correct? And I is nothing but 0 and j equals to 1. Now, can you say, so what is the string I am considering in my given string? My window is this one. This one. Let me just mark it. Where is my cursor? Yep. So this is I and this is j, right? We have already considered the substring a possibility. So what are the new substrings forming here is, the new substrings forming here is b and ab, where the total count is 2. Can you represent again these two in terms of j and I? Definitely I can. What can I do? J minus I plus 1. So it will be I minus 0 plus 1, which will give you s2, right? So there are only 2 to 3 things that you need to remember. This is, or you can say this is the entire pseudocode, right? We'll just seeing a dry run how this is applicable on a 2-pointer and a sliding window technique. Great. And we have to keep on summing this possible substrings as well. That earlier it was 1, now it is 2, right? So we need to maintain a sum variable as well. So we'll just sum plus equals to j minus I plus 1. I hope you're getting. So sum is now is pointing to 3 now. This 1 and this 2. Okay, let us continue. So k is 2. Okay. So what is next? What is next? Just wait a second. Again, so we'll just proceed ahead. Let's go for our third iteration now. So we have the, when earlier it was the frequency of a was 1, b was 1, and now the third character which we are visiting is a. So again this would be increased to 2. And what is the count of distinct characters? You can clearly see in the given frequency area there is only 2 entries which is marked as not equal to 0. So again the count of distinct character is 2 again, right? Again it is not greater than k. So we'll do the same thing. We'll again count all the possible formation of substring into our answer. So I equals to 0 and j equals to 2 this time, right? So what are the substrings that we are considering? So my window here is ABA, right? Which is I is here and j is here. So what are the new substrings we'll be contributing here is, the first is A. Now this A is coming from this one, and not from the first A. It's the third character which we are talking about. And what else? We will have what else? We will have A, then we will have BA, right? Possible new substring, and the other would be have ABA, correct? Yes, this would be our possible substring. So what is the count of the possible substrings here is 3. You can clearly say it's 3, right? How we can again say, again it will be, I will say sum plus equals to nothing but j minus I plus 1, which will give you as 3. So what is my sum here now? 3 plus 3 is 6, right? So we have solved, we have done the iteration for finding the most k for k equals to 2 in this particular substring. Now we need to do this iteration again for k equals to 1 with the same string, or to say, right? So I'm just rubbing this thing here and I'm writing in the left hand side again. So my sum, or let's say the possible all possible substrings with at most k distinct characters. Don't mind my handwriting, guys. Just sit with the copy and pen and a paper, and you can do it in yourself, right? Great. Let us assume again the dry run for k equals to 1. So k has now decreased to k minus 1, which is nothing but 2 minus 1, which is 1, right? So for the ABA, again, we'll start from again I equals to 0 and j equals to 0, right? And we will have a window. We'll have the frequency array A, B, A, B, C, D, and all, right? Initially, everything is marked with 0, so I have visited my first character. I will mark this as 1, right? Okay. What is going to happen next? That my count, that count of distinct characters is now 1, right? And what next? So what are the new substring that I'm talking about? I'm talking about the possible substring that is just A. So I is equals to 0, j equals to 0, and the count total is 1 for the possible substring. So again I will do j minus I plus 1, which is 0 minus 0 plus 1, which gives you as 1. So here let's say sum, or let's say sum is nothing but the total all possible substrings here. So in this case it would be 1 due to this contribution, right? Now let us perform the second iteration. So again the frequency array, let's copy it as same A, B, and C. So the values are 1, and now we are talking about I equals to, okay, so we still have I equals to 0 and j has been we need to move further. So we are at this pointer j, correct? So j in ABA we are at this pointer. So the new character is B. So again we will increase the frequency of the second character, right? The second character. Then what will happen? That count of my distinct characters has been 2. So definitely I'll hit in this case that, okay, my current count of distinct characters exceeding greater than k. Definitely I need to remove the elements, the characters from the starting window, from the starting pointer of our window. Then only I can make sure to get the possible, to get the count of total possible substrings with at most k distinct, right? We just discuss the logic. One sec. Oh, sorry. Yeah, so I'm back. So count is again equals to 2. What else? What else is that again I is equals to 0. So it will hit this case while count is greater than equals to k. We need to start removing our first starting window. So my window, my current window is AB. I is here and J is here, right? So I will the starting pointer of the window is A. So I will decrease its frequency. So it was 1. Let me just change the color. It was 1. I will decrease its frequency to by 1. So it becomes 0. 0. Since I have decreased the frequency, I need to, and since the frequency was also equals to 0, right? So I need to push my pointer. So now my current window is just this, just B, right? And now you can clearly see that your count of distinct characters has also been reduced by 1, and it is just 1, which is not greater than k. So again, what is the possible substring that is forming here is, that is just B. So I is here is 1 and j is also equals to 1. So again applying the formula j minus I plus 1, which will give you as I minus 1 plus 1, which is will give 1, and that is the total possible count of the substring we were forming for this current window, for this current iteration, right? So what is the total sum? What is the total sum is nothing but the total possible substring, right? So I'm just incrementing as 2. Previously it was 1, now it is 1 again, so 1 plus 1 2. Let's go ahead with the third and last iteration, right? Okay, so what is our frequency array looking like? So B has 1, and what is my current window now? My current window is that in A, B, A, I is here and J is here. So this is my current window, and now I will include my next element as well, right? So J becomes here, correct? Now the new element which I have included in my window is A. So I will increase the frequency of, it's A 1, and now you can clearly see the count of distinct characters has again decreased to 2. So again it will hit the while condition, right? And it will see now the start my current window is nothing but B and A, where the I is here and J is here. So I will again start removing or decreasing the frequency of the starting character, that is B. So I will reduce the frequency of B. I will make it to 0. Similarly, since we have reduced the frequency of B, the total number of count of distinct characters has also been reduced to 1, and now it nullifies the condition of while count is greater than equals to greater than K. Correct? So my window has now been just formed to this one, this A. Instead of B and A, it is now focused on just A. So I is here and J is here. Now new I. So I is equals to 2, J is equals to 2, and the possible, if you see manually what is the possible substring that you are forming, that is just A. In this window there is only one character, so that's just A. All the possible substrings, right, of your current window. Again the count is just 1. So you can again do J minus I plus 1, that is 2 minus 2 plus 1, which will give you 1. Correct? So my sum has now increased to 3, right? You can clearly see, you can also see manually here, for k equals to 1, and for string ABA, we need to find all possible substrings with at most one distinct character. So definitely all the possible substrings are nothing but A, B and A, right? So this is the first A, this is the second character, and the third character A, right? The total count is 3, which we are getting in this dry run, right? So we just have to implement this technique in our code. Now I have showed you the dry run. I will not show you the entire pseudo code. For the hint, you can take the help. Where was my pointer? You can take the help of this pseudo code and try implementing by yourself. And at last, what you have to do, you just have to return this particular function. Make a function, name it as at most k distinct, and just return at most k distinct parameters s comma k and s comma k minus 1. You can even return. Can you, yeah, k and k minus 1. Yeah, that's, yes, correct. So I have tried my best to show you the dry run here. So let's just pause this video here, try to code this approach by yourself, and I'll also code it at the same time, then we will resume ahead. Okay, so that's the code in Java. I know it was a bit hectic and a bit a very lengthy video in terms of dry run, but I need to show you for the smaller test case, and you also need to understand, right? So that is why I have shown you the entire dry run. Now please, I highly encourage you also to do the dry run for one more test case by yourself without looking at my screen, and you'll be definitely have a very good go for understanding this question. Let us see a code walkthrough now. So as we discussed, we need to return this thing, and how is the function running? So if k is less than 0, we are returning 0. So definitely if the k itself, that is at most k distinct, if it is even less than 0, then no need to find the possible substrings, right? Now we have some pointers, that is the starting index of the window and the ending index of the window with I and j, and the count is equals to 0, right? And a long answer. So we are storing all the possible answers in the dry, and we stored it in the sum. So here we are storing in answer. So we have a m array to store the frequency, and then we are starting our window. So while j is less than equals to string length, definitely that would be our ending point of our window. So we are checking, if we are not checking, at least we are directly increasing the frequency of our current element, of the current pointer of our window, current ending pointer of our window, right? And we are checking if it is equals to 1, then definitely it has been encountered once while we were traversing into our substring. So we have found a distinct character, and we are doing count plus plus, right? Now we have two cases, that while count is greater than equals to k, we need to start popping out, we need to start removing the frequency from the starting window. Why? Because this function was to implement at most k distinct, not greater than k. At most k means from 0 to k, not greater than k, right? So if it is exceeding k, we need to start popping, and we need to start decreasing the frequency from the starting pointer of our sliding window. We have decreased the pointer. Once it goes to 0, and definitely we have decreased all the instances of our character. So once that is done, definitely your count of total distinct characters have been increased. So that is why we are doing count minus minus, and to achieve this purpose, till this purpose is not achieved, we are always incrementing the starting pointer of our window, right? And at every instance, where the count of distinct character is always less than k, right, less than equals to k, because that stands for the definition of at most k, then we are all the possible substrings forming at the particular stage of the particular window, we are including all the possible substrings into our answer, and we are incrementing the window size to cover the window length for the given string, correct? And at last we are returning the answer. So I have showed you the what to say, the dry run in very detail, so I don't think more understanding is required from my side. Yep. So meanwhile it is submitting. What is the time complexity for this code? We are using a sliding window, that is we are visiting each and every character at most twice, once while adding the window and once while deleting from the window, right? So at most twice. So it would be O of 2n, let's say, but ignoring the constant, what would be the time complexity? O of n. So that's why it's written O of n. What is the space complexity? We are using a 26 array linear array, 1D array to store the frequency, so that is the O of 26, but it is as good as to say constant, that is O of 1. And that is it. We have done this question. Now this was the question that I've done in past, so yep, I have my thread and my copy, so I just showed you. Yeah, let us go ahead with the C process code now. So that's the same code, the same thing we are doing, right? And yes, it is the same thing, I guess. Yep, it's the same. Let's just hit the submit button for this code as well, and I will mention the DSA repository link in my YouTube description. You can go there and find all the source code there, right? Great. Let us end this video here with a good note, and yeah, till then, keep learning, keep growing. Bye bye, and take care, guys.